Hello, I'm Luke from Weaveworks, and I'm going to show you how modern DevOps teams can be cloud native. But actually, my name isn't Luke, my name's Bjorn. I'm a full stack developer in a DevOps team, and I'm busy working on a socks shop for a big client. I'm building this app using containers and microservices because I believe that will allow me to deliver rapidly. So I'm going to start by booting up the microservices app on my laptop. I'm then going to set up a production container platform, deploy the application to it, and check using the visual dashboard that it's come up the same in production as it did in development. I'm then going to demonstrate how my team can do fast iteration on the application using a CI/CD pipeline. I'm then going to demonstrate how we've set up monitoring for the microservices so we can tell that they're healthy. And then I'm going to show you how I've implemented security using network policy and segmentation. So let's get started. First, I'm going to deploy the app locally on my laptop. In order to do that, I'm going to use Docker in combination with Docker Compose and Weave Scope plugged into Weave Cloud. The goal for this section is that we run the app on my laptop and just check that it's working. I've got it checked out here. I can see the Docker Compose file. It's got lots of different services in it. So I can use Docker Compose up-d to start up all of those services. Okay, there we have it. Now I'll just load the app up in my browser. It's just running on localhost because I'm using Docker for Mac. And indeed, you can see I've got the socks shop up and running. Got Weave Cloud open here, and I've got a local demo environment. And I'm going to use that. I've already installed Scope on my laptop, so I'm now just going to run Scope launch. And then that will start pushing metrics into Weave Scope. Okay, there it is, Moby, that's the name of my Docker VM. If I view the instance, I can see all of the containers that are running here. Great, so we've run the app on my laptop and we've checked that it's working. Next, we're going to set up the production container platform, deploy the application to it, and then check that it's the same. In order to deploy to production, we're going to use Kubernetes, and we're going to use WeaveNet as a pod network, and we're also going to use Scope for that same visual dashboard that I showed you earlier. The goal for this section is that we deploy and visualize my application consistently across development and production. Kubeadm init. Cool, so it's given me a command I can run on my other computers. Now I've got 3 nodes up and running in my cluster. Next I can install WeaveNet, because I need to have a working pod network. Hey presto. Okay, next up, let's clone that repository that I forked earlier. Just like I installed WeaveNet earlier, I can install this application as well. So now I can see that application starting up. And hey presto, my application's up and running. That's installed Weave Scope. And in just a few seconds, it should be launched and running. Okay, great, my 3 instances showed up. Let's go and see what the application looks like. Awesome, we have the same components that we had earlier. Great, so we deployed the application in production, and then demonstrated that we can consistently visualize it across dev and prod. Next up, I'm going to show you how my team can iterate quickly using our CI/CD pipeline. So watch out, this is the most complicated bit, because it involves several different moving parts. But I like to call it the ABCDE of CI/CD. ABCDE refers to the app being developed and tested locally, then built using continuous integration of my choice, then pushed automatically to my container registry, deployed automatically using Weave Flux, and deployed automatically to an environment of my choice, in this case Kubernetes. Something important to note here is that the application code goes to GitHub in source control in the first step, and the deployment configuration also goes to GitHub in the last step. So we're using GitHub as a source of truth, both for the source code itself and also the configuration of the application in production. And this is consistent with best practice. So the goal here is that I commit and push a piece of code, and that automatically goes through this entire pipeline and lands in production. Okay, so now let's put ourselves in the shoes, or should it be the socks, of one of our front-end team. Let's suppose the front-end developer just got this email from the demanding client saying that they learned that red buttons have a 30% higher conversion rate than blue buttons, and they urgently want their shop to be updated. Now, it would be really nice if the developer was able to change the color of the buttons on the socks shop without having to understand the details of Kubernetes. So let's go and pretend that we're the developer for a second. We can identify that there's a style.blue.css file that we can change. We can change this background color to red. I mean, I really did say I was a full stack developer. So let's try and, what would it actually take to make that change happen? Well, let's not forget that we said earlier that our CI pipeline goes from an application developed locally into source control, into Travis, into Key, into Weave Flux, and then back into source control so that the version can be configured and rolled back if necessary, and then using Flux into Kubernetes. So let's see that in action. I'm the front-end developer. I just want to make a very simple change to the CSS. How hard can it be? Okay, that's my change. I'm changing the color of the button to red. And with one simple git push, the change from the front-end developer will go into GitHub. And if we go and look in Travis, we're already seeing that build happening. Okay, so now the build has finished. That means that that change has made it through to the Docker registry. And indeed, if I look at the Docker registry, I can see that that new image was pushed. Now what happened in the background is that Flux running inside the cluster automatically updated the version of the image that was running from this one ending 66ED to 45D. So let's go and reload the sock shop. And we can see that the button's been updated to red. Good, that should improve our conversion rate. Great, we've achieved continuous delivery. Our front-end developer was able to push a change to GitHub and have it automatically deployed to production. Next up, I'm going to show you how we monitor the microservices metrics. In order to do this, we've chosen Prometheus, which is a really good fit for Kubernetes, as the technology which will gather the metrics. And then we're going to push those metrics into Weave Prism, which is a service that the guys at Weaveworks run for historical monitoring data. So the goal is that we collect detailed metrics from the application and then are able later to query that historical data using powerful queries. Okay, so I've installed Weave Prism on this cluster, and I can now see that there's a Prism container that's collecting metrics from all the other services. So let's run a load test. I'll start with just 10 requests per second. So I can see the graph showing me the number of requests per second to the payment service. Let's ramp that up and run as many requests per second as we can. Okay, so we can see the number of requests per second to the payment service spike up to about 6. Great, we've demonstrated how we can collect detailed historical metrics from the application and query them later. Okay, last section. We're going to secure the app with network policy and segmentation. The reason we need to do this is that this client that I'm working with is really paranoid and insists that different parts of the application that don't strictly need to talk to each other don't. So in order to implement this, we're going to use Kubernetes network policy description language, and we're going to use WeaveNet's policy implementation to actually enforce it. So the goal is to create a network policy that firewalls unrelated services from each other. Okay, so let's apply some network policy to the shop. We've got some Kubernetes network policy in this folder here, which we haven't yet applied to the cluster. But because it's running WeaveNet 1.7, as soon as we apply this policy to the cluster, it will get enforced. So this policy says a bunch of things like the cart is able to talk to the front end and the orders service. And the cart database is only allowed to talk to the cart service, and so on. So let's check that the policy works when we apply it. So I've picked two services that shouldn't need to talk to each other. The catalog service shouldn't need to be able to talk to the shipping service. So let's start by seeing that the catalog service currently can talk to the shipping service. Got the catalog service here. In scope, I can pull up a terminal, and I can telnet to the shipping service on port 80. I can then speak HTTP and get back a response. So this is not good. It shouldn't be possible for the catalog service to talk to the shipping service. I'm now just going to apply all my policy, and then I should see that telnet to shipping on port 80 is now forbidden. You see those packets are just being dropped. So we've seen that Kubernetes policy, in conjunction with WeaveNet to enforce it, allows us to secure our application after it's been deployed. Okay, so just to recap what I showed you. We booted the microservices application locally. We checked the app in Weave scope. We then installed a Kubernetes cluster, deployed the application to it, and also using Weave scope, we were able to check that it's the same. We were then able to push a change through our entire CI/CD pipeline really simply and easily using Weave Flux. We then set up monitoring for our microservices using Weave Prism, and then we set up network security with WeaveNet and Kubernetes. For visualization and management, we used Scope. For CI/CD, we used Flux. For monitoring, we used Prism, and for network policy, we used WeaveNet. And now we're cloud native. Thanks for watching.